Next week we have a short week, right? 2.5 days.
Riveting.
Yeah, I know, it's very exciting. Okay, that being said, we also have a quiz next week too. Okay, so just a comment on the tests. They're looking really awesome. You guys are doing a great job and you're showing it on tests. So keep up the good work. We're getting into that time of year where we're deciding whether or not to sign up for the AP exam. You all should feel very confident that you should be able to do just fine on this exam. So I would highly encourage that you sign up. You're doing great. So keep that in mind. Let's say some credit for pretty much everybody here. That being said, some of you are like, I wish I was getting a instead of an AB or a B instead of a BC. You always have those corrections to do, so you got that going for you. Also, when you do take the AP exam, I actually will go back over the summer and give you a higher grade if you do well on the AP exam.
That's fine.
So like if you get a 5 in the AP exam, but you only got ABs or Bs during the semester, I go back to both semesters and change them to A's. Okay, if you get a 4 on the AP exam and you don't have ABs for both semester, I go back and change them to ABs. Okay, you get a 3 on the AP exam and you don't have B, at least a B for each semester, I go back and change it to a B. Okay, so I will actually go back and change your grade for the better in the summer. Okay, so there's always an opportunity to do better if you're not getting the grade you want. If in case you're thinking, if you've got like a AB and all of a sudden you get a 3 on the AP exam, I'm not going to go back and downgrade you. So I just feel that's too many class load, so I wouldn't do that. Okay, so talking about exams then, the calculator free response really should have been all done using your Math 8 key. Okay, they give you funky, crazy things to work with in calculus on calculator questions, really odd function. You know, they might give you like the inverse tangent of e to the x squared over x cubed minus 4. You know, they might give you something crazy like that you don't stand a chance of differentiating or doing anything with, knowing what you know about calculus. They do that intentionally because they want you to use your Math 8 key. Okay, they want your calculator to give you a decimal answer for a derivative. Okay, and so here's some advice. We know the final answer should be 3 digits, a minimum. You can have more digits. So if you're going to hit that, if you're going to go with that 3-digit answer, then here's the advice. Anytime you do a Math 8, keep like 5 digits if you're going to use that number in another calculation. Okay, so you know, if they're having you find the derivative at 17, but then they're going to have you take that derivative and use it in a quotient rule, then keep 5 digits so that when you do the quotient rule, then you at that final answer you narrow down to 3 digits. Okay, that will help you get the exact right decimal. Sometimes even if you're off by 1,000th, like you answer 7.672 and the answer is supposed to be 7.673, depends upon the rubric, they may or may not give you that answer point, which is something kind of to get used to. But you'll get used to it through the course of the year. Okay, focusing on today. We reviewed that slope and derivative are the same thing, right? I keep telling you when I say slope, you think, right? Yep, I'm gonna say it so much you're gonna sick of hearing it. You made the connection that finding the derivative on the graph is the same as calculating the slope of that graph. And it's really handy when that graph is linear. You learned that it is very important to first write the chain rule symbolically and then use it as a roadmap. So this last night's notes were focused on tables and graphs. And so to have that, I'll write it up officially here. If we have f of g of x, our function, then our derivative is taking the derivative of the outside, meaning the inside alone, in other words, evaluating it at G, and then times that and multiplying by the derivative of the inside. Okay? And so I'll clean that up for our permanent board record tonight. But so the idea then, using it as a roadmap then, there we go, is you get that written down symbolically and then you put in the X, and then you can find the function value of that X at the inner function. And then that becomes the new Y for the outer function. And then we can talk about then finding the derivatives at two different locations. Okay, and then finally we multiply them together. So if I use the note as an example, this was your tabular example in the notes. It's saying differentiate f of h of x. So I write the derivative of f of h of x. It's the derivative, it's f prime at h of x times h prime of x. Okay, so and then I substitute in the x. Well, our x is 0, so I put in 0 for x. So my derivative of f of h of 0 is f prime h of 0 times h prime of 0. Okay, and then I can find this function value. When x is 0, h is 2. So I can take all of this stuff on the inside and change it to a 2. So now you see I'm finding derivatives at two different locations. I'm finding the derivative of f at 2 and the derivative of h at 0, the original value for x. So derivative of the outer at the y value of the inner times the derivative of the original location. So now I can go back up here and look for those two values. If x is 2, f prime is 3. So that's the first one. If x is 0, h prime is negative 3. Now I can finally multiply them together. Okay, so that's how you use that as a roadmap. I'll put that back up for your topic questions and today's activity. Okay, so how do you get the correct derivative of composite? We set up the symbolic expression first, and then you evaluate the outer derivatives at the y values of the inner derivatives, inner functions. And then we don't have a topic question for day 2, but remember we still have one for day 1 if you haven't looked at that yet. So we have a circuit for today, and then you're going to go back and look at your topic questions from yesterday. And then we've got 3 con for advanced chain rule. And I know I've said it yesterday, I'll say it again. We are going to sneak the chain rule now into everything.
That's scary.
Okay, they love it. It's like, you know, if you're old, you call it the bee's knees. They just love this stuff. So look, we're going to start looking for it everywhere. All right, I'll be around to check notes and to answer questions.